So now that we've made that line of best fit, remember I talked about correlation? Well, now we're going to look at some stuff. We're going to talk about R and R squared. All right, so the correlation coefficient. So besides looking at a scatter plot, and you've made your line, but sometimes you can make a line and it doesn't mean anything. So Carl Pearson, who is like one of the big wigs in statistics, developed the Pearson correlation coefficient in the early 1900s. And it's a numeric number, and it goes between -1 and 1, with 0 being in the middle. And what it does is it provides a measure of strength and direction between that linear association between your x and your y. And if you see here, you can see how it's calculated. And no, you will never have to do that by hand, and please never, ever, ever try. So basically, though, what's going on is there's numerous comparisons between the x and the y. And as you can see here, there's a lot of that going on. The sum of x and y multiplied by each other minus the sum of x, the sum of y. And then if you go down here, you've got a bunch of x here and a bunch of y. Yeah, I'm never, ever going to ask you to do that by hand because we have software to do that. Okay, but let's talk about what R means. Again, I just said it's between -1 and +1. All right. So think of it as 0 being in the middle, and it's almost like it's symmetric from -1 to 1. Because what happens is R equals 0 means there's nothing going on. There's no linear relationship. You can't say anything. If your R is 1, there's a perfect positive correlation. If R is -1, there's a perfect negative correlation. In the real world, this is never, ever going to happen. But let's talk about if it's not -1 or +1. Say I have a value of -0.50. What that tells me, that negative tells me, is that I have a negative correlation, and that 0.5 tells me that I have a moderate correlation. So -0.50 is a negative moderate correlation. So say I had the correlation of 0.20, which is positive, so that tells me there's a positive correlation, but that 0.20 means that it's weak. So what I need to know there is then that I have a positive, weak correlation. So think about if it was 0.80, it's positive, and that would be a strong positive relationship. If I had -0.80, that would be a negative strong relationship. So kind of think of it as the points, like 0.2 is weak, 0.5 is moderate, and 0.8 is strong. And then you just have to look at the positive and negative sign. Okay? So let's look at some. So a scatter plot showing data with positive correlation is here. You can see it's going up, just like it did before. Negative correlation, you can see it's going down. And no correlation is that horizontal line. And when you have these, you don't want to do anything with them. The big deal about this is the calculator is going to give you the R value. You just need to tell me, is it negative or positive? And what is the strength of the correlation? So the next one is the coefficient of determination, and it's R squared. And how you get that is you square the R. It's that easy. So, but for this one, we're going to state it as percentage, and it kind of does something cool. So that R square tells you the percent of variation in your dependent variable that can be explained by the variation in your independent variable. So what it does for me with those exam scores is, you remember I had my Y was my final exam and my X was my third exam. So it's going to tell me, based on a percentage, the variation of the final exam that can be explained by the third exam. Now the 1 minus the R squared, which you're really not going to have to worry about that much in this class, is you do 1 minus the r squared before you make it a percentage. It shows you what of the final exam is not explained by the third exam. So again, it represents the percentage of y that is not explained by the variation of x. All right, so let's consider the third exam and final exam. I got my line of best fit. I got my correlation coefficient. And let's look at that. Ooh, I've got 0.6631. Okay, there's no negative, so there's a positive correlation. And 0.6631, that's a pretty moderate correlation. So I can say from there, there's a moderate positive correlation between third exam and final exam. Now the coefficient of determination, I squared that and I got 0.4397. So approximately 44% of the variation in the final exam grades can be explained by the variation in grades on the third exam. But the flip side of that is 56% of the variation of final exam grades can't be explained by the grades of the third exam. And if you think about that, it kind of makes sense because unless I'm giving you the final exam only covering the third exam, there's other things that are going to be factors that I need to worry about.